Here we have section 7.2, and the first thing I'm giving you, and I'll give you time to copy this, or you can wait till the video comes on and get a copy then, is here are some useful trig identities that we're going to be using over the next couple of days. There are only 2 sections this quarter, this week, only 2. So you might think, oh, it's going to be an easy week. Oh, no, it's not. These 2 sections are very long and complicated. So you need lots of time to do them. This one here uses sine squared plus cos squared equals 1. You're probably not going to use that one much, but you are going to use these 2 versions of it. You know, if you rearrange this one, you can, sine squared can be written as 1 minus cos squared. And in this case, cos squared is going to be written as 1 minus sine squared. And that's because in some of the integrals that we're going to do, there's going to be a sine squared or a cos squared left over, and you want to rewrite these in terms of the other trig. So today's job is how to integrate functions with sines and cosines. That's all we're going to focus on. Integrals of functions with sines of various kinds with cosines. So these 2 identities here will get used. Now, less common, but you are going to use these guys. Sine squared x can be written as that guy. Cos squared x can be written as this guy. And sine x, cosine x can be written as that guy. Have you seen or do you recollect any of these 3 guys? Now, if you haven't or you can't remember seeing them, I strongly suggest that you get them down in a little cheat card somewhere because you're going to use them. And now these 3 guys here are probably the rarest of the 3. In other words, there's only going to be a couple of questions that you'll use these, but you need to know them for those questions. And this is how to rearrange or how to change sine squared to x. So you've got a sine squared to x, but you don't want that. You can return it to a half of a 1 minus cosine 4x. A cos squared 2x can be written as that, and a sine 2x cosine 2x can be written as that. In fact, if you know this answer, do you know you can predict that one? Right, if you assume that this is true, if you think of x's here as just being placeholders, if you replace the x with 2x, do you see how sine squared 2x becomes cosine 4? And sine 2x cosine 2x becomes a sine 4x. So those are the guys, those are the identities that we are going to be using over the next few days. And some others, but you don't need them today, so I'm not writing them down. And now we're going to look at all the different ways in which you could get an integral that uses sines and cosines. We're going to, in a few minutes, start with these situations. Integrals with a sine and a cosine with at least 1 odd power. So a thing like sine cubed x cosine x, right? Something that looks like that. And then we're going to look at situations where you have a single sine or cosine with an odd power. So we're going to look at how do you integrate sine cubed x or cosine to the 5th x. That's situation 2. Situation 3 is going to be how do you do a single integral, an integral with a single power of x or sine x or cosine x, but they're even. So this is going to be things like sine squared x or cosine to the 4th x, right? Just a single guy. And lastly, back to the beginning, how do you do sines and cosines, but when both are even? So we're going to show you how you can integrate sine squared x, cosine 4x. Right. So let's jump right in with the first one. We're going to do situation 1, integrals with sine, cosine, at least 1 odd power. Give me a second, I'll pick some homework questions. They're the easiest ones to deal with. Go. So this is a version of question 1. Suppose we get the integral of 9 sine squared x cosine cubed x dx. So you've got an odd and an even power of sines and cosines. And when you do that, your technique is going to be u sub. And you are only going to do a single sine x as your u sub or a single cosine x. You are never going to do sine squared or cos cubed or anything like that, right? That's not going to happen. It's going to be a single sine x or a single cosine x. And here's the problem. Which one is the right one? What do you think? Sine x or cosine x? I hear cosine x, right? Now, I'm not going to do it, but that's going to happen that you'll pick the wrong one. Can you trust me? If you do a cosine x, you only kill off one of these sine x's. But that means there's a single sine x left over, and that's always bad news. So I'm not going to do that one, which means then, if it isn't one, it has to be the other. So there might be questions where you pick the wrong u sub, but as long as you realize it's the wrong u sub, you just like throw away that scratch piece of paper and you do the other way. So we'll now go through the usual steps. We differentiate it and you get a cosine x. Then you do the crossover. And then you divide both sides by cosine x to isolate the dx. You happy about that u sub? It's pretty standard. Now, we're beginning to hit already the nastiest part. Watch. Sine squared, u squared. Cosine cubed x times 1 over cosine x du. And the cosines cancel, which is nice. But something bad happened. It's not I've done anything wrong, but aren't there some cosine squares left over? And as long as it's an even power left over, you're doing it right, right? You're on the right tracks. And you might think, well, we're stuck because everything here needs to be in terms of u. In other words, everything has to be in terms of sine x, which then becomes a u. But that's what this is here for. Do you see cos squared equals 1 minus sine squared? You see that? So this fella becomes 9 u squared 1 take away sine squared x. Why is that helpful? Well, what do I do next? What does this become? What do I do next?
Then do you just replace the sine squared with a u squared?
Correct. Would you agree that we've now got where we need to be, right? We've got an integral with nothing but u's in it, which is exactly what we want. And then, you know, all sorts of things happen here. You just take whatever you get and you work with it. What do you think I'm going to do next? What do you think I should do next?
Distribute.
And you get this guy. We're happy with that? Distribute? Makes sense? Okay, doesn't this end up being a very simple power rule? Right, just add 1 to the power, divide by the new power. So let's see what we get. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power, plus c. Is this question finished, or should I do one more thing? Let's phrase it a different way. What is the next thing I should do? I interrupted someone who was about to say something.
Switch the sub.
So I'm assuming before she gets cut off, she was asking, oh, That's not good. Hi guys, can you still see me?
Yeah, I can still see you.
Right, I had a little bit of a power twitch, which is not good. So let's just keep going as quickly as we can in case I lose power. Okay, so are you happy about the last stage where you just substitute back to the x's? Does that make sense? Whoa, what's that doing up there? No. Are you seeing a full version of my screen, or is it a little baby version? Because that's what I'm seeing.
I'm seeing a full version.
Okay, I'm going to try and see if I can get the big version back for me. Because kind of makes my life easier if I can actually see things. Right, let's try it again. Okay, I've reset my camera. Obviously, that little, fade in, fade out was not good for my computer. Right, we're done. First guy, at least. Let me go and find another one with a different combination of sines and cosines. This is a version of question 2. Sine cubed y, cosine 8y, dy. Okay, who do you think the u sub should be in this question? Sine y or cosine y? That's all you got.
Sine y?
Agree. Let's check if I agree. No. Why were you thinking sine y before we move on to cosine?
I meant to say cosine. I was going to go with the one that was even. With an even power.
So you were just looking at, I guess some sort of a rule, right? So
Yeah.
have you noticed that you picked the even one, as you said?
Yeah.
Right. And now, again, I'm trying to remember what the variables are called. This is going to be negative sine y. I get that used to x's that when they change the letter, you have to kind of pause a little bit. I'm just going through the standard u sub channel, so a bit quick, but you could always figure that out yourself. So what I've got is sine cubed y, u to the 8, negative 1 over sine squared y, over sine y, sorry, du. And that cancels with one of these, and it looks like we're left right now with that. Does that look okay? Right, we got a problem here, but we had the same problem last time. Don't we have a sine squared left over this time? And if I go over to my little list here, can't you see that sine squared can be rewritten as 1 minus cos squared? And that 1 minus cos squared is the same thing as 1 minus u squared. And hey, isn't that a good place to be now? An integral with nothing but u's. Okay, what's the next line?
Distribute.
Okay, so I have negative u to the 8 plus u to the 10. And then it's a power rule. And return back to, in this case, cosine y's. Okay, that's you seen 2 of them. Is there a little bit of a flow to how these questions work? Now you pick a u sub. In this case, it's better to pick the even one as your u sub. And then you might or might not, in this case you did, get something left over, but you write it in terms of the cosines, distribute, power rule, return. Let me show you one more of this type, and then we'll move on to a new situation. I'm only going to change the question one little bit. So imagine I did all of this work. Try and let Sabrina back in, there we go. Suppose I did all of this work, right? So I'm skipping a lot, but can you trust me that you eventually end up with that? What do you do when it's sine to the 4y that's left over, not sine squared y? How do you think I'm going to treat the sine to the 4th power of y? Because remember, our goal is to eventually get u's, right? Eventually get cosines. So what could I do with sines to the 4th power of y?
Would you treat it as sine squared squared? So you could
I
still use
would.
that formula?
Right, I'd use it as sine squared sine, as you said, and that becomes 1 minus cos squared. Does that make sense? That you can still, as long as it's even powers, can't you get it as a version of sine squared or is 1 minus cos squared, right? You can always return it to the other variable, the other trig function. How do you think I'm going to continue with this question? Because it is a little bit messier than the previous one. How do you think, what would my next algebra line look like? What would I do? What would I do with that? And that's basically the problem, right? What would I do with that?
Would you substitute that for a u?
Oh, you don't need to do that, no. Why don't we just FOIL it out? Wouldn't that be easier? Less work. So what do I get? And I'm saying cos squared. My apologies, you're right. Let me rewrite what I meant to write down, which is this guy. And then do what you said, because I was daydreaming. Right, there. That's what you said, so I agree with you. Now, what do we do now? What do you do with 1 minus u squared all squared?
Now you would FOIL it out.
Yeah, you have to FOIL it out. So can you trust me? Although, what I'm going to do, I'm not sure if you should. Would you agree it's that guy? And then FOIL it out, you know, distribute it, and so what do you get? It looks like a negative u to the 8, a 2u to the 10, and a negative u to the 12. Are we good? Right, I'm putting a dot, dot, dot in this one because we have a lot to cover. Wouldn't that just be a power rule? And then just return back to cosine y's when you're finished. Right, so integrate using the power rule and then get back to the original variable, which in this case would be cosine y again. So there are many trig situations, and we have only looked at one of many situations. So let's look at integrals with a single power. So this is going to be situation 2 now. These are integrals with a single power. So a single power of sine x or a single power of cosine. So let's do, oh, and by the way, they have to be odd. So let's do, as an example of this, and I'm only going to do 2 because that's all we have time for, sine cubed x. And I am not going to do any Anything too special, let's call it that. I'm going to jump right into a U sub. And here is the good news. You only do single sines or single cosines as U subs, right? Agreed? I'm going to rewrite this guy like that. So far, so good. Then I'm going to replace that sine squared with 1 minus cos squared. Now I am ready for my U sub. Who is my U sub going to be?
Cosine X.
Cosine x. Do you notice that if I'd left it as sine cubed, you probably would have said, quite understandably, sine x, and it wouldn't have helped. So whenever you get a sine cubed, a cosine to the fifth, will you pull out just one of these pairs, just one of them, and then you'll have an even number, and that even number you can turn into something that looks like this. Now, if you do a cosine, differentiate with respect to x, you do your crossover, and then you divide both sides by negative sine x, and you've got that guy. So what do we have? We have a sine x, a 1 take away u squared, a negative 1 over sine x, and a du. And they cancel, and you're basically just left with that guy. Which isn't too bad, would you agree? That's almost ready to do. You have a negative u plus a u cubed. Are you happy with that line? Okay, can I dot this one? Would you agree that's just a power rule and turn all the u's into cosines when you're finished? Power rule. And then once you've done it, replace all the u's with cosines and dot. So that's a single power, right? Odd. That's with a sine. Let's do a cosine for the other one. You can imagine, apart from sticking a number like 4 or 5 at the front, would you agree there's not a lot of variation in these questions? There's only a few of them, and then you've done all of them, right? There's not too many things you can do. I want you to think in the same way that we did the last one. So whenever you see a single odd power, pull out one of them, and then leave what's left. In this case, that. And cosine 4. Think of that as cos squared squared. What do you think I'm going to replace the cos squared with? What do you think I'm going to replace the cos squared with?
1 minus sine squared x.
And now that I've done that, can you see who the u sub should be?
Sine of X.
Agreed? Then you differentiate with respect to x, which gives you a cosine. You do your crossover. And then you divide both sides by cosine to isolate your dx. So what I now have is a cosine x times a 1 minus u squared squared times a 1 over cosine x du. Does that look good? Right. Cancel out the cosines. And we're now looking at that guy. Okay, I think I should take this maybe one more line and then leave it. What should the next line look like?
You're gonna FOIL it out.
You're right. Would you agree I can do my dot, dot, dot thing now? Wouldn't that be the power rule? Right. And then turn all the u's into sin x's when you're finished. Are you comfortable then about an integral of a single sine or cosine to an odd power, right? Sine cubed, sine 5, cosine cubed, cosine 5. Now, could you do it for cosine to the 211th power? Theoretically, yes. Would you agree in practice, nobody in their right minds would try it. It'd be horrendously, it'd take you 2 days to do it. So you know you're not going to get fantastically large powers, right? 357, right? That you're pushing it on 7 actually, aren't you? 3 and 5 for sure. Maybe 2 lots of this or a half, and that's it. And that's pretty much every version of that you could ever get. So we are now moving on to, I've got my little list. Where did I put my little list? It should be single even. I just want to make sure I called it the right number, right? Yeah. So let's look at situation 3 now. So we're going to look at integrals with sine x or cosine x, but to an even power. These are a little bit uglier than the ones we've just done. The math is a little uglier. So let's start with a simple one. You are not going to do a U-sub in any of these questions. We are basically going to take whatever they give us and use identities to change them into something we can integrate. Sine squared x can be written as 1/2, 1 take away the cosine of 2x. Well, you accept that that identity is true and therefore I'm allowed to do it, right? I'm then going to pull out the half because I think it's an annoyance. And I'm pretty much finished. I don't need U-subs to do this. Isn't the integral of 1 just x? Okay, be a little bit careful. If you integrate a cosine of 2x, you do get a sine of 2x, agreed? And if it's a negative cosine, you'll get a negative sine of 2x. But what else do you get? Remember the shortcut method. When you integrate the cosine of 2x, you don't just get the sine of 2x. Don't you get an extra little piece that goes here?
You multiply it by 1/2.
Agreed? Right. And then I'll stick a plus C, and that'll distribute the half. Yeah, that was pretty good. Great. Now, there are even fewer of these to do. There's a cos squared one, or I could stick a 10 cos squared. Do you know if somebody sticks a 10 there, well, you just stick it outside and multiply by 10 at the end, and that is the same question. The other version is the 4th power. Nobody's going to give you the 6th power. Will you just trust me that the 6th power would take you forever and a day to do, right? So for practical purposes, it's only going to be 2 or 4, right? So there's very few combinations out there that you need to worry about. In fact, I'm going to do this on a new piece of paper because I realized I'll need more room. And I am not going to do a U-sub. It's a matter of using these guys. So I'm going to take cos squared x and I'm going to square it. Have you noticed that your building block is really sine squares and cos squares, right? That's the kind of the fundamental chunk that things gets done to. Now I could take cos squared and turn it into that, but that's not where I'm going. I'm using these guys, right? These guys here get used when you're doing these questions, right? These identities here. So what have I got? Well, I've got a half, put it in brackets, 1 plus the cosine of 2x, all squared. And if you, I don't think this is much of a tidy up, but can you imagine me squaring the half and getting a quarter? And now I've got that guy. Try to take it slowly. Are you okay about a half square becoming a quarter? I just wanted that fraction out the way. What do you think I'm going to do with this? No U subs allowed. It's not going to be U sub. What algebraically will I do?
Foil it out.
I will. If you FOIL it out, you'll get a 1. You'll get 2 cosine of 2x, which isn't too bad. And then you got this ugly guy. Now, I know how you integrate 1. Can't I use the shortcut method for that? So I'm good with that. But this fella here needs to be changed, because I don't know the integral of cos squared anything, including 2x. So what will cos squared 2x turn into? It's over here somewhere. Cos squared 2x, what will it turn into?
Half times 1 plus cosine 4x.
Do you see why you need these identities handy? Just so you can say, okay, I need to change it. What am I changing it into? And exactly what you said there, it's going to be 1/2, 1 plus the cosine of 4x. Right, the next couple of lines, I'm just trying to make things look pretty, and I'm not sure I'm going to be successful, but I'll do the best I can. That 1 and that half can add together. Are you comfortable with what I just did there? You know, add the 1 and a half together, you 3 halves, and you know, just did my bits. Right, this is ready to go. The number 3/2 gets you 3/2x. If you integrate the cosine of 2x, you get the sine of 2x times a half, so that cancels out, and you just get sine 2x. And if you do this guy, you will get the sine of 4x times a quarter. Well, you've already got a half, so a half and a quarter get you an 8. And then that gets you 3/8x, 1/4 of these guys, 1/32 of these guys, plus c. Would you agree that is a much uglier one than the other ones? It just is because it is. Can you imagine why we don't do cos to the 6th power of x? Can you just, you can see, if that's that bad, can you imagine what the next one up would be? It would be even uglier than that one, right? And so let's not even think about it, because it's not something you're going to see. Quick recap. Are we happy about sine cubed cos squared? These kind of questions. Are you happy about sine cubes? These ones. Are you happy about sine to the 4x, which is these ones? So there's only one left. Integrals with sines and cosines, both even. And if we can do that, that's a big chunk of situations covered with. So I'm going to show you 2 versions of these. If these are rare, and these are very rare, these are even rarer, because there's only a certain number of combinations of both of them being even that you're likely to make. And one of them is both of them squared, and the other is one of them squared and the other fourth. That's the only 2 that we need to worry about. So sine squared, cos squared. I am going to do this. And you are not going to be doing any U subs. It's all going to be trig identities. Can anybody see a trig identity over here that we can use to replace that with something? Sin x, cosine x. What can I replace it with?
Half sine of 2x.
Are we comfortable with that guy? Now, if you square this, you get 1/4 sine squared 2x dx. And I don't like quarters, so I'm just bringing them out to get that guy. Now, I want you to look at this list and find a sine squared 2x that we can change this guy into. What can we change sine squared 2x into?
1/2 times 1 minus cosine to the 4x.
Are we good with that? I'm going to bring this quarter and this thing out and get an 8th here. I just like doing that because I'm careless. And so the less fractions involved, the less mistakes I make. Right, so I'm not doing anything special, I'm just pulling out a half. This guy's ready to go. You can integrate 1, you get an x. If you integrate a cosine, you get a positive sine. But because it's 4, you get a quarter. And then you just distribute the 8th. And you are done. Seeing if I can find the guy I'm looking for. Yes, I found him. This one is question 8, or at least a version of 8. And they've got a number, so I might as well put a number in. We have sine squared t cosine to the 4th t dt. Last question for today. Both of them are even. No arguments about that. Agreed? This is not a biggie. I'm just doing it because it makes my life easier. So hopefully that's not a big deal. Okay. Oh, shooting space, it happened again. Oh, you're still here, guys, right? I'm getting flickering and all that. Carry on. Well, we did good to get this far. Okay, I'm not going to push my luck because who knows how long this is going to last for. I have no idea what you're looking at. Are you looking at the whiteboard now? Yeah, no, okay. You're looking at it now? Okay, let's go for it, guys. What on earth am I going to do with this fella? I mean, this is the first time any of you have probably seen this, so don't worry about just thinking outside the box, upside down, back to front. Give me something to do.
Would you factor it out?
And tell me how you're going to do that, because that might be the right direction.
Sine squared t and cosine square.
Mm-hmm. Oh, and square.
Yep.
Can I maybe just change a little bit, almost what you did, but actually separate them out into 2 distinct cos squares instead of cos squared square? That's a good start. Focus on this guy. Is there another way of writing sine squared and cos squared that might be of help? Didn't we see that guy not that long ago?
You do sine times cosine squared.
You would. Now, see the cos squared guy? Let's use this identity. Now, that half I'm going to pull out. This guy is going to get replaced by 1/2 the sine of 2t. And this guy is going to be 1 plus the cosine of 2t, because I've already pulled that half out. Now I'm going to pull this half out. And I am left with the sine of 2t, 1 plus the cosine of 2t dt. So far, so good. Now I want you to think for a few seconds. And I want you now to think u sub.
Would the 1/2 sine 2t still be squared? And
Oh, thank you. Which means that'll be a quarter, which means we've got 8. Right. Oh, that's going to change what I'm about to do then. But just a little bit. I'm going to split it into sine squared 2t, 2t, plus, I'll put a bracket around that, plus the integral of sine squared 2t cosine of 2t dt. Right. Forget about this guy. Can you see a u sub? What u sub would get me this fella? What u sub could I use to integrate this one?
Would you use sine of 2t?
Correct. And can I just say you'll have to finish that yourself because we don't have time. And unfortunately, I have a sine squared 2t left over. Is there anything I can turn the sine squared 2t into?
half times 1 minus cosine 4t.
If I planned this right, it would be 1 take away cosine of 4t. Right, that mess there says 1/2, 1 minus the cosine of 4t dt. Would you agree that eventually I could integrate that? And u sub will do that. And good luck, it's question 8. But we've done about 3/4 of it. So last name.